Hi everyone, we are back for a warm-up to start us off today. So in your packet, you just want to find the sheet that says warm-up, coronavirus stats. So I found these stats last week, right before we left, and they go up through March 10th, so it's pretty timely. Of course, it's different now, but it's just a good place to start. And so if you look at the table, hopefully what I want you to do is complete this worksheet first and then come back to this video to see anything I'm going to add to it. So I want you to give it a try first. Make sure you fill it in. Use Statplet.com to create the scatter plot or your calculator, whichever you prefer, and then you can follow through the guided questions until the end and then come back to this video and see what kind of debriefing you need to add. All right, so first, let's look at this scatter plot. I have it pulled up right here. And so I went ahead and added the line through it, but this is definitely a strong pattern. As you can see, it's positive because it's increasing. And then it's not linear, though. This line indicates a linear pattern, and this does not fit. So we're definitely going to go with a very strong, positive, non-linear, it looks more exponential association between day and number of cases. So we always want to have the strength. Use the wrong color. I'll change it to regular red. Direction, form, and then you want to have context for sure. And so strength, direction, form, context are the main things that you want to do when you're describing the form of the distribution. Okay, moving on, use the applet to find the least squares regression line, write the equation. So on the applet, you just click calculate least squares regression line, and then write it down. Remember, we use the form y hat equals a plus bx. And this is a linear model. Even though we wrote a number 2, it's not linear, but we are going to use a linear model because that's all we know to do in this level of AP Stats. And so make sure you always define your variables. And don't forget the word predicted. That is key when you have the hat on the y. All right, so number 4, use the line to predict. And so we plugged in, February 23rd was day 17 according to the table. Plugged in 17. It was predicted that we would get 8,759.555 cases. The residual is your observed minus your predicted. So if you look in the table, we actually got 2,055. And so actual minus predicted is the formula for residual. We get negative. That means our prediction was too high. And so when you interpret it, you want to make sure you include that with units. All right, now this next part, number 5, right before number 5, asks you to complete the table. So the table says predicted number of cases. What you can see here is that I plugged in each day for the predicted number of cases, and then I got my predicted numbers. I just plugged in 1, 5, 9, 13, etc. And then for the residual, you do 330 minus, so observed minus predicted. Observed minus predicted for every single time. And that's how we get all of our residuals. To plot them, you just... we already gave you the graph. The line y equals 0 is in the middle usually. And this is called, that's because there would be, the residual would have been a perfect prediction. And this is called a residual plot. These are useful because it shows all of the residuals plotted on one graph. And then it helps us to see that anything above the line, all the greens, those are where our observed was greater than our prediction. So I'm going to say prediction too low, and then anything below the line, our prediction was too high. All right, so if we keep going, number 7, do you think the regression line is a good fit for the data? Why or why not? Explain using the residual plot. So we already had our scatter plot. Oops, that's not where that is. Sorry. We already had our scatter plot showing us on Statplet that this does not fit. this line does not fit this data. But if you look at the residual plot, which they have already drawn too, if you look at the residual plot, that also should back that up. So what I wrote was no, it was very inaccurate in the beginning, middle, and end. So it was inaccurate here, here, and there. There's only 2 spots where it was about right. And then you can see how it has this sort of quadratic pattern. And that means that there was a pattern in the errors. And so a different model would definitely be better. So what we want to take away from this is when a residual plot has a clear pattern, then a linear model is not appropriate. And when a residual plot has no clear pattern, so it's just randomly scattered and you can't see a shape, then a linear model is appropriate. So that's going to be the takeaway from this little warm-up. It's just a quick introduction to what a residual plot is and why we use it. I'm going to just fit to the height so you can see the whole thing all at once. If you need to copy anything down, just pause the video and look here. And then I will also go back to the last page and you have the same thing. So that is your warm-up for today, and then we are going to do the next sheet, or the sheet right before that in your packet as well, on the GPAs. Thank you for listening. Stay tuned.